Hey everyone, welcome back. In today's video, we are going to break down one of the most powerful tool in Java, that is a collections framework. So the Java collection frameworks is an unified architecture for storing and manipulating groups of objects. So it provides ready to use classes and interface to handle data structures like lists, sets, queues, maps, and etc. So the package here we are using is java.util, and you can just use the asterisk, like it will get you all the packages or classes available within util. And why we use collection framework? Let's say you are building an e-commerce site and you'll need a cart that grows dynamically, a set of unique product categorized, and maybe a queue for processing orders. So collection like ArrayList, HashSet, and priority queue make all this easy. So yeah, means it's reusability, like pre-built data structures like ArrayList, HashSet, and HashMap helps in reusability, and algorithms like it has a built-in short search, shuffle, and reverse features. Then, like, again, it's a type safety, generic supports, like I can see, instead of directly using a list, you can use a generics. What are the object types you can specify within or while creating the list or map objects. Then flexibility, like dynamic resizing, ordering or unordering collections are available. Then consistent API to manage different types of data structures. So let's see the hierarchy here. Basically, collection framework has three interfaces, like collection, map, and queue. So collection and map interface are a part of collection framework, but they are two separate verticals. And map is not a child of a collection interface, and both can be used with a generics or can be used independently without a generics. So we can't use any primitives like in float or double with a generics, and generics should be any object type. So here is the classification, like within Java collection frameworks, we have a collections queue, a map. Map has HashMap, tree map, and linked HashMap. Then queue has priority queue and DQ. Like in detail, there is other diagram as well. What are the interface and class and how it is extended or implemented, we'll see later. So a list has array list, linked list, vector, and stack, again is part of vector. Then set has set, reset, and link has set. So main interface in collection framework. So here in this picture, like the blue one are interface and green are class. So the hard lines are extended and dotted lines are implemented. Like priority queue implements queue, array list, linked list, vectors, stack, implement interface list, and DQ extends queue, again sorted set extends set. This is on a collection framework which contains list, queue, and set. Again, the map interface, you can see this is interface, and this is class. So map has sorted map, and again sorted map, like tree map is implemented based on the sorted map. Then again linked hash map and hash map we have. So basically the collection is the root interface of all collections, which contains list, set, and DQ. And list, which is ordered collection and which allows duplicates, has array list, linked list, vector, and vector has a stack. Then we have a set, which is won't contain any duplicates, which is ordered and unordered, and it is sorted, which has hash set and linked hash set. Then again it is there is like sorted set which extends a set, and TreeSet which implements sorted set. Then we have a queue, which is like FIFO structure, first in, first out. It has priority queue. Priority queue implements queue, and DQ extends queue. Array DQ implements DQ. Then comes like as I mentioned, like HashMap. It's a key value pair which has HashMap, remap, linked HashMap, and all. So let's break down each. So I don't go in detail. It's just an introduction to the collection framework. Let's see each interface and its child classes high level, and we'll see in other videos as well. Like each interface will be available in other videos as well. So first is the list interface. The characteristics are like ordered duplicates, and duplicates are allowed inside a list interface. Then access based on index, and multiple null value can be allocated. It has some child classes which already discussed, like we have array list, linked list, and vector class. So the vector class, like a stack is a subclass of vector. So just simple example, like on all collections framework, like either it's ArrayList or linked list or set, we can add the means basically why we are using this is to add the data, retrieve the data, or order it, sort it, just to do the operation. There are lots of algorithm available to search the element or sort the elements within the list. So for those purpose we are using a collection framework. So it's a simple example here, like as I mentioned, each classes has a method or options to add the elements, retrieve the elements, remove the elements. We'll see how we can do those things. So as I mentioned, like first we need to import java.util package, like just import everything within the util package. Then here's a simple example, like I have created array list, means this is a parent interface. Then I have child class called ArrayList. So the recommended is like adding the generics, whatever the type you are inserting within this ArrayList, add it within the brackets. Then adding, like we have add method, we have remove methods. So if you want to retrieve a single object or a based on index, you can use a fruits dot get and pass the index. And or if you want to get all the items, so just to iterate over it, like, or you just print the or add it within the sysout. So to iterate, as I mentioned, like we have for block based on the counter, or for each one also can be used. Here you can see the duplicate is allowed here. In the set it's not. So the features for set interfaces, it's like there is no duplication allowed here, and it is unordered. Array list is ordered, and linked HashSet is ordered here, and again TreeSet is sorted. Like if you want to uh, sort all the items, like either it is numbers or characters, you can use a TreeSet. Again, HashSet is unordered. So set has some a child class that is HashSet, which is shown above, and linked HashSet is a subclass of HashSet. Then shorted set, navigable set, and tree set are subclasses of sorted set. And here is the process to add. It's a similar way, like just use add method, and this is the generic. So if you are using int, you can use int and integer. Then again, if you are using or if you are storing any object as object type itself. Then comes the queue. So it has these characteristics, like follows a first in first out feature. Then used in messaging system or task scheduling. And duplicate objects are not allowed. Insertion order is not preserved, and null cannot be inserted. We have a priority queue. So again, as I mentioned, if you want to store integer type, you have to give integer in the generics, and this is how we need to add. So in the set and our list, we use remove method, but we have remove as well as a poll, and which will like The poll method will remove the content and it will show you the removed content. Remove will just remove, and a peek method will peek, like it will just print the character, like first character or friend character or friend element from the queue. Then comes the map interface. So again, map interface has a character, like it's a key value pair. It's a dictionary kind of thing, like key and value can be any type, like key can be integer, or value can be string. Again, key can be string and value can be integer as well. It can be any type, and keys are unique here, so you can't add duplicate keys, and it again, it's not part of collections. So here I've used put method to insert the values. Like here you can see I'm having integer and string. Like integer is key here, string is value. So ID and the name. I'm using HashMap. So there is a process to iterate a map. I will show it in the IDE, and how collections are categorized here. So which allows duplicates, like list allows duplicates, and queue it depends. Then key values, like key won't allow duplicates. Then ordered, you can see it is uh, available in list, in set, HashSet, 10 link HashSet are ordered. Again, it's based on the features like duplication, ordering, null allowed, and use cases. Like list can be used in array like cases, and if you want to assign unique values, you can go for set. Key value pair, the dictionary thing, I can go for map. Then task scheduling kind of things, you can go for queue. So there are algorithms which use all of these collections classes, like for list, for sorting the elements, or storing the unique elements. There are number of algorithms we'll see in later videos. So real world use cases are like, let's say if you are building the project, a simple project on shopping cart, like for ordering items, you can go for list. So let's say if you are building Android apps, so most of the times you'll use adapter. For adapter, you'll use list to store the adapters. So then username, like for unique and unordered elements, so you can go for set. A dictionary, again, a map, like dictionary example, like mapping the words and all, you can go for map collection type. Then scheduling the job, you can go for priority queue. Browsing history, like going backward forward, you can use dq, which is a double-ended queue. So we have a utility class as well. By default, you can sort, reverse, shuffle, or frequencies. You can use the utility class called collections. Like you can use a collections class and pass the list, set, map, whatever it is, and you can use this utility. Like if you want to sort the list or reverse the list, you can go for collections utility class as well. So always use generics for type safety, which is recommended. So let's see a simple example in IDE. So here is a simple example. So I have a list, set, and map. So to iterate list, we already seen how we can iterate through for you can see here I'm passing the list here. It's a placeholder name, the variable, which will helps to iterate through the list and print the elements within the list. Same goes for set, the same approach. So you have to pass the set and give some variable to print the element within the set. And so both, you can see I have added a generics here. With the set as well, I have added generics. And let's see, like here you can see I have added duplicate values for set and map. I will see whether it will print duplicate values for both or not. Then the map, as I mentioned, for map, the approach is the same, but here we have a method called entry set. For each entry set, we'll print the key value pair and get the entry, each entry and each entry set. Like we have to use dot entry set method and dot entry, uh, and you have to specify whether it's a string or integer. And entry is the variable. So the syntax you can see here, the collection uh, type, then the variable, then the mm, reference for that collection. So here the difference you can see, this the reference is to within the block, like within the loop, and this reference is what you have created. So let me execute this. So here is example, you can see like it will, which will print the student list. You can see it has printed the duplicate value, but in case of set, only unique values are printed, like science, math, history. Then to print or to loop map, you're seeing like the string and the score. So this is how you iterate through the list, set, and map. And here is a simple example, kind of real time thing, like a cab booking system. So I have a list for available drivers, like it's a hard coded value like driver 1, driver 2, driver 3. So allows order duplicates if needed. Like I have used a list for storing drivers. Then a customer, like customer will be unique. So I have used set, then map for mapping customers and drivers. Then I have created a book cab class uh, to perform the actions. Like let's say if you book the cab, I'll be adding it to the map, saying like a map to the or mapping drivers and the customers. Then again checking whether there is any available drivers or not, or the customer is already assigned to any driver or not. So first, let me execute this. So here, yeah. So you can see first I'm booking the cab, like I'm using a class here. So alias is a customer. So you can see in the class I'm getting the customer, drivers, active customers, and booking maps. So customer name, again it's a hard coded. I'm adding alias and available drivers, driver 1, driver 2, and driver 3, and active customers. Here you can see to track the active bookings, and customer driver map. So at last, I'm just iterating the customer driver map. So here you can see first, I'll check whether active customer contains the customer name. So if not, I will add it to the list. I'll get the driver's name, first available driver. I will assign it to the assigned driver. Then I'm creating the booking map, like customer name and assigned driver. So that's why, like, whenever I have created a class, like I have called the class allies assigned to driver is printed, allies assigned to driver. And at last, like again, the third case, you can see it's a duplicate one, allies, and you can see allies already booked a cab will be printed. Means first it will check whether there is any he is in the active customers and the customer name or not. Like because active customers I have listed here, which is already like the customer who already booked the cab. And then again the current bookings, you can see the customer Bob driver, driver 2, then customer alias driver is driver 1. So if I add other guy as well. So alias assigned driver 1. So first it will assign the driver, available driver is the first driver itself, because um, I'm removing it from list and then assigning directly to the first customer. Then Bob will be assigned to driver 2. Then if I try to call again with allies, it will say he already booked the cab. Then Rahul assigned to driver 3. So when I try to assign a driver for another customer, it says no drivers available, and these are the current bookings. So this is a high level, simple example on collections, which I have utilized all the required collections classes. Thanks for watching.